All right. Hello, everybody. This is actually a really fantastic turnout. This is my first in-person meeting since the start of the pandemic. And between the hybrid models between Zoom and in person, this is bigger than any meeting of the SAS that I've ever presided over. When I was president for a couple of years, we never had this big of a crowd. So I'm really, really pleased with sort of what the pandemic has brought to the Seattle Astronomical Society, and also what the board, the outgoing board, has done for the society. They've really brought in a lot of new faces and made this a more interesting group to be a part of. So I think they've done a really good job. I wanted to talk about Mars tonight because I'm really enthusiastic about phenomena that have to do with the pieces of the solar system moving and ways in which you can kind of observe that through a telescope. And so what I want to do is talk a little bit about what a Mars opposition is and set up a little bit of the geometry for you. I had a fun time this week playing with a Python package so I can make some visualizations that'll kind of help us see what's going on with geometry of the Sun, the Earth, and the Mars when we have an opposition. So basically what's going on is the Sun, Earth, and Mars line up so that Mars is on the side of the Sun closest to the Earth. A lot of you may already know this. Earth is on the inside track, and it overtakes Mars about once every 2 years. It's just a little bit over 2 years. It's like 25 or 26 months that it takes for this to occur. And so you just saw in the little animation there how Earth did a little flyby of Mars. But one question I wanted to see is whether or not y'all know what it's called when they're lined up like that on the other side of the, so Mars is on the opposite side of the Sun from Earth. Does anybody know what that alignment is called? No, so opposition is when they're all, so when Mars and Earth are on the same side of the Sun. When they're on opposite sides, it's called a conjunction. That's right. And specifically, which kind of conjunction? Superior conjunction, meaning that the planet's on the far side of the Sun. It's with the inner two planets, with Venus and Mercury, it's also possible to have an inferior conjunction, which is where the planet crosses between Earth and the Sun. But today we're going to talk about opposition, and well, why do we care about this? And the biggest thing that matters to us as amateur astronomers is that Mars is closer, so we get a much better look. This is important because Mars is generally extremely difficult to observe through a telescope because of its small size. So it's quite a bit bigger. This is the image that whoever did the publicity for this meeting tonight found online. I actually found it on Sky at Night magazine's website. I thought this actually illustrates this really well. You can see how small Mars was in May of 22 compared to how it's going to look in November and December of this year. So it's really, you get a big benefit from being closer to Mars. The other thing I want to point out in this diagram is it also shows another phenomenon that we can observe this time of year, and that is when we're making our flyby of Mars, Mars will actually appear to move backwards in the sky. So this is kind of an exaggerated path. Mars normally in our night sky is kind of moving from right to left, from west to east. But as we fly by, it's actually going to temporarily appear to move in the other direction. This is what we call retrograde, and we'll talk a little bit about that also in just a little bit. The other thing that's kind of neat about opposition is that we can take advantage of the geometry to efficiently send spacecraft to Mars. So it's not as simple as the spacecraft just taking like the shortest route right there when the planets come close together at opposition. We have to launch the spacecraft a little bit in advance, in anticipation of the opposition. And the idea is so that the spacecraft only has to lift that little distance between Earth and Mars in this close configuration. It's a much more efficient way to get a spacecraft from our orbit to the Mars orbit. I won't go deeply into that, but that's one of the advantages of waiting for a launch window like this. So first thing I did is I plotted the distance between Earth and Mars for about 30 years worth of cycles. And at the bottom, when Mars is the closest to Earth, I've put these red dots. And you can see when Mars is closer to Earth at those opposition moments where the red dots are. Mars will appear a little bit larger than it will when it's a little further away. And you can see that not every opposition is the same. So back in 2003, that was the best one we'll probably see in our lifetimes. You can also see here in 2022, see if this cursor works here on the screen, yes. So here we are, this is our 2022 opposition, and this is actually better than it's going to be for about the next 3 or 4 oppositions. So this is one of the better ones to watch for the upcoming years. Not as good as 2003, we'll look at that one a little bit too, but this is definitely a better one than average. The other thing I want to comment on is that the closest approach of Mars doesn't actually happen when we have that opposition geometry, when we have Sun, Earth, and Mars in alignment. The closest approach actually happens just slightly before. So for us, that's going to happen on November 30th, whereas the opposition is going to be on December 7th. And it's going to be a whopping 1% larger on November 30th, so it'll be 7.2 arc seconds in diameter versus 17 arc seconds in diameter. And I wanted to just compare what Mars looks like compared to Jupiter when it was at opposition back in, does anybody remember when the Jupiter opposition was? 6 weeks ago? Yeah, or so. I can't remember the exact date. But yeah, Jupiter, has the same type of phenomenon with Jupiter, where when Jupiter's at opposition, it looks larger. We can see it even better. But when you compare Jupiter and Mars, you can start to see why we have a hard time observing it as amateur astronomers. So here's a little animation that I made that kind of shows where what the geometry is when the close approach occurs. And I probably made this video go a little bit too slowly, but originally I had it made so that it was way too fast and you couldn't see what was going on.
You had me at, I made this.
I made this, yeah. So closest approach, you can see that the planets aren't quite in a line. But then about a week later, boom, they're in alignment. There's your opposition. Okay, so close approach, opposition, they're close, but not the same. Okay. So, and I'd also like to take a moment to talk about what is an arc second, because it's a little bit hard to visualize what we're talking about when we say Mars is really small. All the pictures I put up on my screen show Mars a lot bigger than it actually will appear through a telescope. So an arc second is 1/3600th of a degree, and to compare, a moon is about half of a degree, so 1800 arc seconds. And raise your hand if you've seen this image before with the different ways to measure, distances in the sky. So the moon, and it's actually, it blows my mind a little bit, but the moon only covers about half a pinky's worth of sky. It always seems that so much bigger to me, but when you hold your finger up, sure enough, it only covers about half of the moon. Okay, so that just gives you kind of some scale of what you're seeing in the sky. But now Mars is going to be 17.2 arc seconds, so that's about 140th of your pinky. That's hard to visualize. Or that would also be like a dime if somebody held it like roughly 2.5 football fields away. So we're talking something really small. Pretty incredible that we're able to see stuff like this at all. That's why I love telescopes so much. And as we talked about, some oppositions are better or closer than others. So 2022 is better than the next 4, and this is another diagram that kind of shows you that. So here's our 2022 opposition. On the y-axis here, it's showing you the angular diameter at opposition. So this one back here in August of 2003 was about 25 arc seconds. It's a lot bigger than we're going to see this year at 17.2. But the next few are significantly smaller. So this is definitely a get while the getting is good kind of a thing. The other big advantage to the opposition this year is that Mars is really high in the sky. And maybe you probably remember this diagram if you think back to probably high school astronomy or physics. and we talk about the seasons and the Earth's tilt. Well, it just so happens we have winter because the northern hemisphere is tilted away from the sun this time of year. So you can see that over here, the winter solstice. We've got the North Pole pointed away from the sun. What that means is, because remember where Mars is on the other side of us from the sun. So that means that the northern hemisphere is basically pointed at Mars. So Mars is really nice and high in the sky right now. Back in 2003, when we were observing it, it was actually, you know, more in like the time between the summer solstice and the autumnal equinox, when Earth's pole was pointed more away from Mars. And so it appeared really, really low in the sky. So even though it was quite large, it was difficult to observe because we were looking through so much atmosphere. We'll talk a little bit more about the atmosphere problems in a bit. So yeah, this year it's going to get up to 67 degrees off the horizon at its very best. So that's pretty cool. Let's see, I think we covered everything there. I also wanted to cover this really quickly. So I had very recently gotten into astronomy when the 2003 opposition occurred. How many of you remember the 2003 opposition? Anybody? Not that many. That's great because we got a lot of new folks to this. The internet lost its mind. This was kind of the heyday of chain letters. So people would forward letters, you know, somebody would send them some crazy thing and then they'd send it to everybody in their address book. And I remember getting this email over and over and over again. And it basically went like this, that there will be 2 moons in the sky on August 27th. The next time this cosmic event will happen will be 37,000 years. Share this information as much as possible with your friends because no human being alive today will be able to behold this incredible phenomenon a second time. They were saying in some cases that some of these emails were saying that the Mars would appear in the sky as big as the full moon. Yeah, so anyway, it goes on and on and on. But there were a whole bunch of memes, of course, that were born from this, and there was one that I was trying to find. I think this one was done in jest, but somebody who had seen this this email over and over again did a meme saying that Mars will be the size of a tortilla on your windshield. But actually, one of the claims that was in a lot of these emails was that the moon at that time would appear the same size as the full moon if you looked at it through a telescope at 75 power. And that is actually true. So if you had a 75x worth of eyepiece in your telescope, what you see in the eyepiece would look about the same size as the moon does to your naked eye, so about half a pinky. And just to compare, so here's a diagram, a little video of the 2003 opposition, and you can see why they came so close together. This is what's called a perihelic opposition. So it happened when Mars was at its perihelion, meaning in its orbit where it comes closest to the sun. So of course, if it's closer to the sun, it's therefore closer to Earth as well as we pass by. So this gives you some information. The distance at that time was 0.37 AU. This year it's going to be more like 0.54. By the way, an AU is an astronomical unit, so that's the average distance between the sun and the Earth. So a lot of the distances we measure in the solar system use that measurement instead of miles or kilometers, but you could use those units as well. And as I mentioned before, the angular size was 25 arcseconds. So about 1.5 times bigger than we'll see it this year. So it's a pretty big difference. But you can see the altitude that it got off of the horizon was only 26.5 degrees, and that's very low. You're looking through quite a lot of unsteady air when you look that low. So at that time, if you used about 75x, it would look about the size of the moon. This year, we have to go to 105x to get that same size on Mars. And so, yeah, this just gives you kind of a side-by-side comparison of the 25.1 arcseconds versus 17.2. Those are scaled there. The other thing is I just took some frames from those two videos showing where the perihelion of Mars's orbit is. So you can see in 2003, it was almost bang on that perihelion point when opposition occurred. This year, it's nowhere near it. Any questions on any of this so far? Or online?
Yeah, we got a comment.
It's funny actually. FOMO. A little story about the 2003 FOMO. I lived in Colorado at the time, and people were so excited about it, and they wanted to observe it on the perfect day, right? Okay, when it was the biggest, when it was at closest approach. So because of my scheduling conflicts, because I had to work, I went out the night before the optimal day and looked at it, and it was amazing, fantastic. Next day I had to work anyway, so I wasn't going to be able to observe it. But what happened was our monsoon came, and the very next day was cloudy, and it was cloudy for a month and a half afterward. So, and people had, when I say they lost their minds, you could not buy a telescope at that time if you wanted to, because everyone, I don't know if you all know what happened during the comet at the beginning of the pandemic. Everyone wanted a telescope and they weren't available, and that's exactly what happened with Mars. So people had these brand new shiny telescopes that they couldn't see Mars with because they waited one day too long. So I think FOMO is a real thing here. Yes, I think that might be the case. They say that you get 1 week of bad weather for every inch of aperture you buy in a new telescope. But anyway, so the moral of the story is, even if it's not perfect now, go out and see it now, because this is Seattle, folks. I mean, we're incredibly lucky to have this clear weather in November. And we are going to have a great shot at seeing this tonight. So, if you're here in person, we're going to go out and look at it. And if you're at home, I highly recommend taking some time, taking your scope out tonight or tomorrow, but definitely before Saturday. Okay, so the other thing I want to talk about that's kind of neat is, and briefly mentioned earlier, is we will see Mars in retrograde. And I think this is most interesting if you don't know a whole lot about what's going on with the orbits, like, say, some of maybe ancient astronomers. You're not really sure what the wandering planets are in the sky. You just know that they sort of consistently seem to move from west to east. But then every now and then, like once every 2 years, you see it, reverse and go the other way, and then reverse again and come back. So I just thought that was kind of an interesting thing that bears mentioning. There's a cool, I put a link at the end of this presentation, but Keith Crum actually put me onto this. NASA has their Eyes on the Solar System, which is an interactive model of the solar system. You can go online and really see where the orbits are and watch Mars fly by Earth. It's really cool. Okay, that already played. And this is my favorite part of all of it, is that we are also going to get an occultation on the same day as the opposition. So we have an opposition occultation. Exactly, say that 3 times fast. So this is kind of unrelated. It just happens that the moon is going to pass right in front of Mars that evening. So Mars will disappear behind the moon from our perspective. And this map shows where on Earth it will look like that. If you're outside of this zone, like say you're down somewhere in South America, Mars and the moon will actually look completely separate. It's only from the perspective of the northern latitudes that Mars will go behind the moon. The other thing is if you're right at the edge of this zone, you'll see what's known as a grazing occultation. And this is a photo taken, a time lapse, taken by a really well-known astrophotographer, Terry Legault, and in Lisbon, Portugal. And you can kind of see Mars just going just barely beyond the rim of the moon. And one of the things that's really interesting about these is that the exact timing of the disappearance and the reappearance of Mars are determined by mountains and craters on the moon. So the times that I'm going to give you in just a moment so that you can, put it on your calendar to go out and watch this event, it's only approximate. It's going to be within a few seconds, but it might not be quite right because it's going to depend on exactly where on the moon Mars is going behind. So if there's a mountain there or there's a crater, that's going to affect the exact timing of the occultation. And scientists can use this extremely precise timing of occultations, not just Mars, but stars and asteroids and all of that, to kind of enhance our knowledge of lunar topography. And there's an organization called IOTA, International Occultation Timing Association, that leads trips to go time these things. And they have, they contribute data to these types of projects. So if that's something you're interested in, you can check out their website.
So we're gonna see. Mars set and a Mars rise from the moon.
From the moon. Yeah.
And who's leading us in that party over there? That viewing party?
Yeah, and before I move on from this, the reason I like this so much is that this is a chance for you to see through your telescope the pieces of the solar system moving. It really gives you a sense of scale. I think it's the only time I can just really visualize what's happening. I can look at a diagram of an orbit on on a screen or on paper, but it's when you experience these solar system bodies moving past each other. I mean, a solar eclipse will do this, or it's possible to watch Mercury go in front of the sun with a solar filter. Again, you just get this incredible sense of scale and distance and the way that gravity is pulling things. That's why I like occultation so much. Oh, okay. Dave Hoover asked, what phase of the moon will we have? Does anybody know the answer to that?
Pretty close to Pohl, or 99%.
And yeah, why would that be? Yeah, because the moon is basically in opposition as well. Yeah, exactly, because the moon has to be in the same position to cover Mars. Yeah, no, that's a very good. I'm glad you asked. I was hoping somebody would. Yeah, so that's why we will have a full moon. Oh, Pat, yeah.
I've seen pictures of occultations though in the gibbous phase.
Yeah, okay, yeah. Pat says that we've seen pictures of occultations in the gibbous phase, or even on this this photo that I have on the slide, you can see Mars is going by the kind of a darkened part of the moon in the background there. And in many ways, that's more interesting because you don't see the lunar topography except for when Mars passes behind it, which I think is pretty cool. And Jeremy, did you have a question?
I have it right now.
It's about an hour. Yeah, actually here, that's the next slide. Yeah, so this is just, if you want to do a screenshot of this or, take a photo, this gives you kind of a rundown of everything you need to know. So the occultation disappearance is at about 6:51, and it reappears about an hour later at 7:50.
Yeah, I'm on Stellarium. That's a great. Stellarium is a great web program too. You can project anything, so I'm like looking at Mars.
That's awesome.
That's cool.
Oh, yeah. I mean, okay. So for those of you who have computerized telescopes, one thing I thought would be super cool is set up your telescope, do your alignment in the early part of the evening before the occultation starts, center on Mars, watch it disappear, and let your telescope just track across the moon, and then hopefully it'll still be on there and in exactly the right spot when Mars comes back out. It's going to go through more or less right through the middle. Yes, then we should worry. I agree.
You think in terms of like gain and all that, the brightness will be about the same? Or?
No, not even close. So that is one thing that. Oh, okay. I'm going to paraphrase the question. The question was whether or not the brightness, I assume between Mars and Moon, would be about the same if you're trying to photograph it, which is a very good question. And no, they're nowhere close. The Moon is significantly brighter than Mars, especially when it's full. And so it's going to be a challenge to image, to be honest. you may have to do some tricks with, you know, for those of you who are into HDR. I'll talk a little bit more about photography in a minute, but that's probably one of the most challenging parts about imaging it is the difference in brightness. Yeah. Any other questions? Okay, we'll just keep moving.
We'll take some. I'll let you know when questions come in chat, and then we'll take some at the end.
Okay, that's fantastic. Yeah, I'm going to get into now just observing it with the telescope and a little bit of, I'm going to get into taking pictures. I did a talk a couple of months ago over at Bickerson's, which I think we have a recording of, and I also posted a link online so you can see my slides. So if you have more questions about imaging or you want to talk to me about that, that's great. But I didn't want to keep you all here all night long since we're all excited to go out and image and view Mars. So when you're observing with a telescope, just note that viewing and imaging will be best when Mars is at its highest point in the sky. The night of opposition, that's going to be around midnight. And that doesn't mean you shouldn't look at it before it's at its highest point in the sky, but it'll probably just get better and better the higher it goes. Mars will be the brightest object in Taurus and has a really distinctive reddish cast. There's a very red star in Taurus, but you'll be able to distinguish it because Mars is quite a bit brighter. You want to shoot for about 30 times magnification per inch of aperture. So for example, if you have a 4-inch telescope, it's going to support about 120 times magnification. You can try going a little bit higher, and that'll work especially well if the conditions are very calm, the seeing is good, the air is steady, and also if you have really good quality optics, you can usually push it a little bit higher than that. But that 30 times per inch of aperture is a really reasonable number to shoot for. If you go higher, you may notice that of course, the brightness is going to get quite a bit dimmer, and also you're going to lose some sharpness, and that may be important for distinguishing surface detail. I put 2 finder charts here. You see it moves just a little bit between December 8th and December 1st. So December 1st being about where it is when it's at the closest approach, and December 8th being, that's in UTC, that's the date of the actual opposition is December 8th. It would be December 7th here. Which telescope is best? Well, pretty much any telescope is going to see Mars reasonably well. Any telescope with 100 magnification maybe or more will show Mars reasonably well. Larger telescopes will usually support higher magnification, and that will be an advantage here. Good quality refractors give extremely contrasty and sharp images, and those are often preferred by visual observers. I brought a small refractor tonight so you can test this out. Actually, this is a great comparison because we've got a really large Schmidt-Cassegrain for you to check out, which will have the best resolution out of all of them. But this will have a nice, sharp, contrasty image, this little refractor, and then the Dobsonian is also going to do an extremely good job on Mars. So you'll get to see how all 3 very different telescopes will do a good job. That one is about 3.5 inches. Yeah. The larger aperture of the Schmidt-Cassegrain or the Newtonian may be preferable for photography, and this is really just because it's able to resolve smaller details. So if you're taking pictures, it's going to be all about trying to get the tiniest little details possible. When you're doing visual, sometimes you can't perceive those tiny details as much. It's more about having the contrast and the sharpness. But yes, quality of your gear is really going to pay off for planetary observing. Filters can help you see some of the details because Mars, the features are fairly low contrast. So you can use filters to help enhance contrast. And I just put a little chart here. Generally, like oranges and yellows and reds are going to help you see sort of those blotchy surface details or Maria. Dark yellow can help pull out clouds if there are like some kind of dust clouds or other clouds on Mars. Polar caps, green will make the polar caps stand out like crazy. And then light blue can help enhance some low contrast features. And you're not going to be able to find really fine details. It's going to be more about identifying major prominent features of Mars. So things like Syrtis Major, Terra Meridiani, you probably can see this. Maybe Olympus Mons is fairly low contrast. It tends to be hard to see. Valles Marineris might be a little bit hard to pull out, but it has a little bit more contrast there. So those are the types of things that you can kind of identify.
Yeah, I was able to, like, for the last opposition, I was able to see I mean, expectation setting, you're not going to see that, but even just seeing a little speck of white, like at the bottom of the pole, just mind blowing. It's like I'm looking at a pole, a polar ice cap of another planet. It's just mind blowing to me, at least. So,
Yeah.
yeah.
And I think Aaron's point there is good. These images that you're seeing are, even though they're generally taken through amateur telescopes, they're better than what you see through your eyepiece with your eyeball. And that's because of the post-processing that goes into planetary imaging. So you can actually generally pull out a lot more detail. And I'll give you a little taste of how that works, but I'm not going to go super deep into it. Just in a nutshell, if you're doing photography, the kind of camera that we recommend for doing planetary photography is really a glorified web camera. It's actually got a fairly small sensor. You don't need a large sensor because the planet's so small that there's no point in having like a big DSLR sensor. And you want a lot of focal length, a lot of magnification, because you're trying to enlarge it as much as possible. And so this is the type of thing that we recommend for taking pictures. And then, of course, if you've looked through a telescope before, you've seen this, where you have this kind of distortion that's caused by the atmosphere. And this is what we're talking about when we say seeing conditions. Some nights are better than others for the stability of the air. And so one of the ways that we try to beat this when we do planetary photography is by taking a video, perhaps 1,000 frames long. And then when you go back in and post-processing, your software can grade each frame of the video based on how sharp they are. And then it can stack the best of the frames together to give you your final image. I personally have never imaged Mars, but this is one of my lucky imaging pictures of Jupiter, so it's not real impressive in the video that I shot. But when you run it through the software, this is the software that grades it and stacks it. And you can select a different percentage of your best frames to stack. Then you start to see how the image improves. This is still not amazing work. I mean, I'm sure you've all seen better planetary photos online. But this is fairly realistic for what you could get in a backyard in Seattle.
There's a great red spot there.
Yeah, we can identify the great red spot there. However, this is another person from one of our customers from here in Seattle, and he takes absolutely stunning planetary images from his backyard using a Celestron Evolution 9 1/4. So it's a little under a 10-inch scope, and this was taken very recently. So I expect he'll have even better shots. I'm guessing I'm going to watch his Twitter feed because he posts them all the time, and since we've had such nice weather. But one thing that I thought was really cool in his Twitter feed is he took his telescope out and pointed it at whatever this is, a sheep. And you can see how when you take a picture of the sheep, it's really blurry with that much focal length at that incredible range. And that's because of the seeing conditions between the telescope and the animal. But he applied the exact same techniques that we use for sharpening planets to his image. So he had a little video, and he went through and graded the frames based on how good they are. He stacked them together and used a little sharpening technique. And he got a much sharper, crisper view of the same thing. So I thought this was a pretty nice, explanation of what we're doing with planetary lucky imaging.
Is he part of the SAS? We need to talk to this guy.
I don't think I know. I would love it if he was part of the SAS. We've actually featured his planetary photography on our website. It's on the very front page of our website. He's, by my estimation, one of the best in the area. And he got these results, I mean, I think he started cranking out images like this within a week of buying his telescope. So.
And I'll just say it's like planetary photography is definitely the learning curve from that to deep sky is like a whole other ball game. So like planetary is a fantastic way to
Yeah.
get going. It's just like, and the learning curve is like, as someone who went from not knowing anything about imaging, after a couple tries, you can start to see it coming together, and the programs are free. And so
Yeah. Yeah, absolutely. And the time commitment is low, and you don't have to have incredible equipment to do planetary photography. So I recommend giving it a try. You can even do it with your cell phone, with the camera in your cell phone. Just fit it right up to the eyepiece of the telescope. You can try that tonight if you want to. I didn't bring my bracket to hold it, so it may be a little bit goofy trying to get the phone in the right place. Oh, all right, Josh brought a bracket, so we're good.
What would be the time frame difference for imaging Mars versus Jupiter?
Oh,
Like length of time to rotation?
oh, okay, yes. So this is a good point. One of the things you have to be mindful of when you're imaging Jupiter is that Jupiter has a 10-hour rotation period. So it rotates once on its axis every 10 hours, which means that it's a large planet. It's moving very fast. So if you're taking a short video of Jupiter and you're planning to stack those frames to make an image, you have to make sure that the rule of thumb I use is you try to keep your video under 1 minute. With Mars, you don't have to worry as much about that. The length of the Mars day is about the same as an Earth day. So it moves a lot slower. So you can take your time with that. Yeah, Josh.
I have a machine learning model that I've been working on still for us to take longer videos of Jupiter than we do machine learning model will correct the rotation of Jupiter so that you get some better data. Now, technically they can focus on that original image, but they would.
Yeah, sign me up for that. So Josh Max has a machine learning algorithm that will essentially derotate Jupiter, right? So if you have frames where Jupiter has rotated, it will sort of put them back where they should be. And this is actually a really cool approach to it, doing it via machine learning. There are other ways too. There's a program called WinJupos that will, from the timestamp, figure out how to derotate them also. So the one pro tip that I have for you for cell phone imaging is that your camera in your phone is going to try to overexpose the planet. This is a picture of Jupiter. This is a pretty typical picture of Jupiter through a cell phone. The real cool move is to, at least on my iPhone, you just tap the screen and then drag your finger down, that little sunbeam icon, drag it down, and that will lower the exposure. And then suddenly you'll be able to see the cloud belts and stuff on Jupiter by just not overexposing it. Yeah, that's a useful one. If you get nothing out of tonight other than that. A lot of folks have DSLRs and are really enthusiastic to use them for photography in general, for astrophotography in general. However, it turns out that because it's such a big frame, the planet's just going to be tiny in there. The DSLRs typically have a lot of pixels, so if you're trying to take a video, the frame rate isn't very good. That's not that big of a deal for Mars, but it could be a problem for something like Jupiter when you're trying to take a really fast sequence of images.
Shot Jupiter like 10 years ago using a Canon T3i that has that 640 by 40 crop mode.
Oh yeah.
Really nice on the Canon cameras to like bring it down to a pixel scale.
Yeah.
It only uses like a real close.
Yeah, and I put this in the bullet points here. So Jeremy was saying that some cameras, you can actually crop down the video so that you're not downloading the entire frame as you try to take video. You just have to be careful. Some DSLRs do that by cropping the frame. Some of them do it by just not using some of the pixels in between. So you actually get a lower resolution. But you know, whatever. If you've got a DSLR and you want to use it to take pictures of Mars, by all means do it. You'll probably get something pretty good, better than you thought even. And I think that's where I'm going to leave it for tonight. I just wanted to put up a slide with some additional resources here. I mentioned IOTA earlier. Also my planetary imaging talk that I gave at Bickerson's back in, I think it was August. And this is a URL to the slides if you would like to see that. That goes more in depth into the planetary imaging part. And then AutoStacker is that free piece of software that we use to stack the images. It's really straightforward and easy to use. And the Eyes on the Solar System app that you can go to online and play around and mess with the pieces of the solar system And I just wanted to give a shout out to the folks who created the Skyfield Python library because it was incredible to work with. I was able to create all of these diagrams using the JPL ephemerides, and it was really, really easy for a sort of, I guess I would call myself a junior programmer, like a junior. I don't think even covers it, like baby programmer, home hobbyist programmer. But anyway, I'd like to open it up for questions if there are any questions tonight.
Round of applause for Stephanie. Yay!
Dave. Oh, yeah, okay. Question was, would I recommend a moon filter for looking at this? Maybe. Sometimes when you look at a really bright object that's small, like Venus or Mars, the light will actually refract off of imperfections in your eye, and you'll see spikes on the planet. So if it's too bright like that and it looks really weird, you might try either a polarizing filter or a neutral density moon filter, and that'll knock down the brightness a little bit and hopefully prevent those spikes from happening. So that's not a bad plan. Any other questions?
Yeah, like anyone here that has never imaged or seen a planet or interested in telescopes or basic imaging stuff, that's the most exciting period because you have this whole, it's like, we have a SAS member, his name's Gustavo, and Gustavo told me one time, it's like, his telescope is a spaceship, and I really like that because it's like, it takes you there. So it's getting a little nerdy, but I love it, yeah. But, yeah, well, he has 4 telescopes. He has 4 space. He has the Enterprise. He has the
Quick question.
Yes.
Want to touch on Mars rind real quick?
What was it on Mars?
Rind, when you get your picture, he's got that gray around the edge.
Oh, I don't know if I'm familiar with that.
Ah, okay.
There is, so if you image a planet close to the horizon, you will often see a little bit of the separation of colors, almost like a prism, and that's due to refraction from the atmosphere. So that's actually something you'll see quite often in planetary photos. And there are optical devices that will compensate for that, but also you can take your separate red, green, and blue channels and realign them in post-processing, which helps with that as well. I don't know if that's what you're talking about, but that's
Yeah, you pretty much covered it. That's it.
Okay, cool.
And if anyone's curious, like if they're not able to join us tonight, please look at the SAS.seattleastro.org website. We have a host of different star parties that are happening. Some of them this time of year, some of them might get canceled, but we have enough of them. I think that you should be able to make a few of them in the coming months while all 3 planets are out. And it's not like after December 8th, Mars it's not worth seeing anymore. It'll be great for the many coming weeks to come. So there's still time to pop by or Ballard and Cloudbreak Optics too to talk to Stephanie or Matt, both SAS members, and or give them a call too. But
Awesome.
yeah, question?
Yeah, you just had a Uranus.
A Uranus.
Yeah, that in opposition. So how is that viewing?
That's a good question. So the question was, how is the Uranus opposition, which I think occurred fairly recently? Yeah, I happened to see that when I was looking intensely for Mars phenomena. I'm like, wow, Uranus is right there too. I don't know. The only time I've ever seen Uranus through a telescope, it really has just looked like a blue-green object. Yeah. So I can tell that it's a disk, but I haven't been able to see any kind of detail with it. Now, right. In fairness, I haven't tried to observe it during opposition either, and that doesn't happen nearly. Well, it happens once a year, but yeah, that's cool. That's worth looking at as well. Cool. Any other questions from online?
Well, and
and I'll check in with Jeremy too, and then Stephanie, feel free to hang out, and Stephanie and I will also get our telescope set up to.
Let's get these guys observing.
Yeah, I think we're gonna tag team here, and we're gonna aim one of the telescopes at Saturn, one of them at Jupiter, and one of them at Mars. So that's what's gonna be going on here. Any more questions online? Doesn't look like it. Okay.
I have a comment.
Okay.
If anybody needs any help, contact Wendy and she'll get a hold of me, and I'm pretty much willing anytime to help somebody.
And who's that?
Steve Case.
Steve Case. All right. Wonderful. Thank you. All right, so everybody here, we're just give us a few minutes to set up, and we have more snacks here, and I'll try to get a space-themed playlist going here for some students while we wait. There's bathrooms and water as well too around here if you haven't been in the space before. All right, everybody online,
Hello?
Thank you so much for coming. Yeah.
Hello?
Oh, Mark, you had a question?
Well, yeah, more of a comment. One of the things that Stephanie touched on was things that are observable on Mars. And you can see, of course, the dark and the lighter areas on Mars and the poles. One thing that people often mistake is when they look at Mars and think they see the polar cap, when often a phenomena that you see is a polar hood, which are clouds over the pole, and it can often be the opposite pole of the one which actually has the polar cap visible. So,
Wow,
so sometimes
really
you'll
cool
look at Mars and you'll see sort of a polar cap on both ends even, and one of those is usually just clouds.
Wow, that's really cool. Even the clouds. Yeah, the dog agrees as well too. Exciting stuff. Do you have any images, or have you tried to image something like that before?
Sure. You can pick it up. What I would suggest is just order it online
Kind of
and
mute.
put it for
All right.
pickup,
Well,
and then I'll just hand it to him.
I don't know.
Yeah, they're 40, and you can select your size. Sarah did all of this. Yeah.
I want to see your shirt here.
I spent way too much time on it, but it was fun. Yeah, I've never had a chance to do that before.
And I am so embarrassed because I knew it was.
I know. I was
Pretty cool shirt, isn't it? Yeah. So are you still online?
Yeah, we're gonna shut down for everybody online. For everybody online, we're gonna shut it down now so we can focus on the in-person viewing. So thank you everybody online for joining. We're gonna shut it down. So thank you.
I wanted to show you something about your